Our universe is a place of awe-inspiring grandeur. When we look up at the night sky, we are greeted by a spectacle of cosmic proportions. The Milky Way stretches across the heavens, a river of stars that has inspired wonder and curiosity for millennia. Each point of light represents a distant sun, many with their own planets and possibly even life. The vastness of space is almost incomprehensible, with billions of galaxies, each containing billions of stars. It's a reminder of how small we are in the grand scheme of things, yet it also ignites a sense of connection to something much larger than ourselves. We gaze up at a night sky filled with stars, planets, and galaxies. The beauty of the cosmos is a testament to the wonders of the universe. From our vantage point on Earth, we can see only a fraction of what lies beyond. Telescopes and space probes have revealed a universe teeming with activity, from the birth of stars in nebulae to the violent collisions of galaxies. Each discovery adds to our understanding of the cosmos and our place within it. These celestial objects exist on a scale that dwarfs our planet. The sheer size and distance of these objects are mind-boggling. For instance, the Andromeda Galaxy, our closest galactic neighbor, is over 2.5 million light-years away. Yet, despite these vast distances, we are able to study and learn from these distant objects, thanks to the advancements in technology and science. Yet, hidden within this vastness is a microscopic world equally as impressive. Just as the universe is expansive, the microscopic world is intricate and detailed. This realm is filled with particles and forces that govern the very fabric of reality. It's a world that we cannot see with the naked eye, but through the lens of a microscope, we can explore the complexities of matter at the smallest scales. This subatomic realm is filled with particles so small they are invisible to the naked eye. Atoms, the building blocks of matter, are composed of even smaller particles called protons, neutrons, and electrons. And within these particles, we find quarks, the fundamental constituents of matter. These tiny particles interact in ways that create the diversity of elements and compounds that make up our world. It is in this world, where the very fabric of reality is woven, that we find quarks. Quarks come in different types, or flavors, and combine in various ways to form protons and neutrons. These combinations are held together by the strong nuclear force, one of the four fundamental forces of nature. The interactions of quarks and the forces that govern them are key to understanding the structure and behavior of matter. These minuscule particles are the fundamental building blocks of matter. Without quarks, there would be no protons or neutrons, and thus no atoms. The study of quarks and their interactions is a field of physics known as quantum chromodynamics. This field seeks to understand how quarks combine and interact to form the particles that make up the universe. They are the smallest things we know to exist, and they hold the key to understanding the universe's structure and evolution. By studying quarks, scientists hope to unlock the mysteries of the early universe, moments after the Big Bang, when quarks and other fundamental particles were formed. This research not only helps us understand the past, but also provides insights into the future of the universe. Their discovery revolutionized our understanding of physics. The identification of quarks in the 1960s was a major breakthrough in particle physics. It provided a deeper understanding of the fundamental structure of matter and led to the development of the Standard Model, a theory that describes the fundamental particles and forces in the universe. Quarks are not just tiny specks of matter, but rather the fundamental constituents of protons and neutrons. These particles are essential for the formation of atoms, which in turn make up all the matter we see around us. The interactions of quarks within protons and neutrons are governed by the strong nuclear force, which is responsible for holding the atomic nucleus together. They are the heart of every atom, the essence of everything we see and touch. From the smallest grain of sand to the largest star, quarks are the building blocks of the universe. Understanding these particles and their interactions is crucial for unraveling the mysteries of the cosmos and our place within it. The study of quarks continues to be a vibrant and exciting field of research, pushing the boundaries of our knowledge and expanding our understanding of the universe. To truly grasp the significance of quarks, we must first understand what they are not. Unlike atoms, which can be broken down into smaller parts, quarks are considered fundamental. They are not made up of anything smaller. They are the most basic units of matter. These particles are not solitary entities. They exist in a perpetual dance, bound together by forces of unimaginable strength. They form composite particles like protons and neutrons. These protons and neutrons, in turn, form the nuclei of atoms. Without quarks, there would be no atoms, no molecules, and no matter as we know it. The existence of quarks is fundamental to the existence of everything we observe. These subatomic particles are the building blocks of protons and neutrons, which in turn form the nuclei of atoms. Without quarks, the very fabric of matter would be non-existent. Without them, the universe would be a very different place. The stars that light up our night sky, the planets that orbit them, and the life forms that inhabit these planets all owe their existence to quarks. Stars wouldn't shine, planets wouldn't form, and life itself wouldn't exist. The energy produced in stars, which is essential for the formation of planets and the sustenance of life, is a direct result of nuclear reactions involving quarks. It is a humbling thought that something so small can have such a profound impact on the cosmos. The intricate dance of quarks within atoms is a testament to the complexity and beauty of the universe. These tiny particles are not just theoretical constructs. They are real, tangible entities that scientists have been able to observe and study. Scientists have been able to study quarks in laboratories. Through sophisticated experiments and advanced technology, they have been able to probe the mysteries of these fundamental particles. Through experiments involving high-energy collisions, they have revealed the properties and behaviors of these elusive particles. These collisions mimic the conditions of the early universe, allowing scientists to gain insights into the fundamental forces that shaped our cosmos. These experiments have confirmed the existence of quarks and provided insights into the fundamental forces that govern the universe. The study of quarks continues to be a frontier of scientific exploration, promising to unlock even deeper secrets of the universe. There are 6 types, or flavors, of quarks, each with its unique characteristics. These flavors are up, down, charm, strange, top, and bottom. The up and down quarks are the most common and the lightest. They are the constituents of protons and neutrons. The other 4 flavors are heavier and more exotic, created in high-energy environments like particle accelerators. While we can't see quarks directly, their existence is evident in the behavior of the particles they form. Their properties dictate the properties of the larger particles. The study of these properties helps us unravel the mysteries of the universe. Section 5. Quark interactions, a symphony of forces. Quarks are bound together by the strong force, one of the 4 fundamental forces in nature. This force is incredibly powerful at short distances, far stronger than the electromagnetic force that governs our everyday interactions. The strong force is mediated by particles called gluons, which act like glue, holding the quarks together. The interaction between quarks and gluons is a dynamic process. Gluons are constantly being exchanged between quarks, creating a sea of virtual particles. This constant interplay of forces and particles is what gives protons and neutrons their stability. Section 6. The enigma of confinement. One of the most intriguing aspects of quarks is their confinement. Quarks are never found in isolation. They are always bound together within composite particles. This phenomenon is known as quark confinement. It's like trying to isolate a single end of a string. It's simply impossible. This confinement is a consequence of the strong force, which increases with distance. If you try to pull 2 quarks apart, the energy required becomes so great that it creates new quark-antiquark pairs, preventing the isolation of a single quark. Section 7. From the Big Bang to our being. Quarks played a crucial role in the universe's evolution. In the moments following the Big Bang, the universe was an incredibly hot and dense soup of elementary particles. As the universe cooled, quarks combined to form protons and neutrons, the building blocks of atomic nuclei. These nuclei, in turn, captured electrons, forming the first atoms. This process of atom formation was essential for the subsequent formation of stars, galaxies, and ultimately, life itself. Section 8. Quarks and the ongoing quest. The discovery of quarks has revolutionized our understanding of the universe. It has provided a framework for understanding the fundamental constituents of matter and the forces that govern their interactions. But our exploration of quarks is far from over. Scientists continue to probe the mysteries of quarks using powerful particle accelerators, such as the Large Hadron Collider. These experiments help us delve deeper into the nature of matter and the fundamental laws of physics. Section 9. An invitation to explore. The world of quarks is a testament to the power of human curiosity and our relentless pursuit of knowledge. These tiny particles, which are the fundamental building blocks of matter, have intrigued scientists for decades. Their discovery has opened up new realms of understanding about the universe and our place within it. It reminds us that the universe is full of wonders, waiting to be uncovered. From the smallest particles to the vast expanse of space, every discovery adds a piece to the puzzle of existence. The night sky, with its countless stars and galaxies, serves as a constant reminder of the mysteries that lie beyond our reach. By exploring the microscopic world, we gain a deeper appreciation for the vastness and complexity of the cosmos. Each quark, each particle, tells a story of the universe's origins and its ongoing evolution. The beauty of a mountain range or the serenity of a desert landscape at sunset can be seen as a reflection of the intricate dance of particles that make up all matter. So the next time you gaze up at the night sky, remember the tiny quarks, the fundamental building blocks of reality. These particles, though invisible to the naked eye, are the foundation upon which the universe is built. Their interactions and behaviors shape the world we live in and the cosmos we explore, the fundamental building blocks of reality. Just as a rock formation tells the story of geological processes over millennia, quarks reveal the underlying principles of physics that govern everything around us. By studying these particles, we unlock the secrets of the universe, one discovery at a time. Their story is a reminder that the universe is a place of endless fascination. Every sunrise and sunset, every natural phenomenon, is a testament to the intricate and beautiful workings of the cosmos. The curiosity of a child playing with a science kit mirrors the curiosity that drives scientists to explore the unknown, and that the journey of discovery is far from over. Whether we are exploring the depths of a cave or walking a remote trail, each step we take brings us closer to understanding the universe. The adventure of discovery is a never-ending journey, filled with wonder and excitement at every turn,